In this chapter, we will provide you with a general introduction to programming. Let's start with the overview of the chapter. First, we will zoom into the steps of the programming process. We will then provide a sneak preview on object-oriented or OO programming. We will then discuss the various types of programming errors as they are likely to occur when you start writing your first software programs. We'll then zoom into the principles of software testing and provide coverage of software maintenance. We will conclude the chapter by discussing the key principles of structured programming. A program, also known as an application, is a set of instructions to solve a particular problem. Programming is then the activity of writing a program in a particular programming language, and the person writing the program is then referred to as the programmer. As an example, you can think of the calculation of the BMI, or body mass index. To do so, a program requires two inputs, being the height and the weight of a person. Once those inputs have been provided, the program can calculate the BMI as the weight divided by the height squared. It can then report the BMI as part of its output. Actually, the program can also come up with a second output, which will mention whether the person is overweighted, yes or no. Remember, if the BMI is bigger than 25, then you are considered to have overweight. So, on top of the BMI, the program can also report a message saying whether the person is overweighted, yes or no. Here you can see the programming process, and you can see it's basically a cycle. It's an iterative process as opposed to a step-by-step sequential process. So we start by gathering the requirements of the problem. Before you start programming, you have to have good comprehension of the problem that you wish to automate. Gathering requirements can be done by means of interviews, surveys, Q&A questions, and so on. Once you have a thorough understanding of the requirements, you can start making your first program design. This will typically be done in some kind of high-level language, such as by using pseudocode or by using flowcharts, as we will discuss in a moment. Once we have a careful design of our program, we can start coding it in a particular programming language. You can think of various types of programming languages, like Java, Python, etc. This programming language, or more specifically, this program written in a programming language, will then be offered to a computer in order to translate it to machine language. In other words, it will be translated to zeros and ones, language which your computer can understand. This will be followed by a testing phase. In the testing phase, the aim is to detect any types of errors that may have entered into the programming step. Once the program has been carefully tested, it can be deployed. Deploying a program means that you're going to bring it into production. You're going to actually start using it. Once the program has been used for a while, it may well be that there is some maintenance that is needed. Maintenance means that new functionality should be added to the program, or the program needs to be updated to a new software version, for example. Again, note that the programming process is an iterative process, so many of these steps may have to be reconsidered multiple times as you start writing your programs. An algorithm is a procedure needed to solve the problem. So an algorithm is basically a step-by-step overview of a solution to a particular problem. Think about the problem of calculating the BMI, for example. To facilitate the development of an algorithm, we can make use of pseudocode or flowcharts. Pseudocode is structured English without strict grammar rules. So it's a kind of high-level language that will allow you to develop a first solution for a particular problem or a first algorithm to solve a particular problem in a user-friendly language. Besides pseudocode, we can also make use of flowcharts. A flowchart is a visual representation of an algorithm. Visual representations are typically considered to be very user-friendly. Note that we can use both types of both aids, pseudocode and flowchart, in a complementary way. Here you can see an example of pseudocode. Remember, there are no strict grammar rules for pseudocode. This is the pseudocode that we may want to use to solve our BMI problem. So first, we're going to ask the user to enter his or her height. This will be followed by asking the user to enter his or her weight. Then we have a check on the values. If the height is 0 or the weight is 0, then an error message will be displayed saying that incorrect input values have been entered. Displaying error messages is also very important as you start designing your programs. Now assume that incorrect input values have been entered, then we need to return to the beginning. In other words, we need to start over again and ask the height and weight of the user. Assume now that correct input values have been entered. In other words, that the height is not equal to 0 or the weight is not equal to 0. Then, the next step in our pseudocode calculates the value of x. X actually represents the BMI, and it's calculated as the weight divided by the height times the height. Once we have done this, the program can finish and a message can be displayed stating your BMI is followed by the value of x. So you can see this is pseudocode. This is a very user-friendly way of starting to design a first solution or algorithm to the problem of calculating the BMI. Another way of doing this is by using flowcharts. And a flowchart provides you with a graphical representation of the various steps that you have to go through as you solve your problem. It makes use of different types of flowchart symbols, which you can see listed here. First, we have a terminator, which shows the start and stopping points of the program. An arrow shows the direction of the process flow. Typically, this may also include an exchange of data. A rectangle represents a process activity, a rectangle represents a process step or activity. A diamond indicates a decision point in the process. Then we have a next symbol which represents a document or report. A rhombus represents data used as inputs, outputs to or from a process, and a cylinder represents a data source, which will typically be a database. Here you can see an example of a flowchart corresponding to the design of a solution for our BMI problem. Remember, we start with a first symbol to indicate where the program starts. So we start right here. Next, we have an activity which will ask for the user height or the user weight. Then we have a decision point indicated by the gray filled diamond. This decision point will verify whether the weight equals 0 or the height equals 0. If yes, then this will be followed by another activity which will display an error message. Once the error message has been displayed, we will return to the activity of asking the user height and user weight. For the new user height and weight, it will again be verified if both are 0, yes or no. If no, we can then successfully compute the BMI in another activity. Once the BMI has been computed, we can display the BMI and stop the program. So you can see this is an example of a flowchart. It's a high-level representation of a solution or algorithm to a particular problem. It is very user-friendly, and it can also be used as a communication aid to talk to our end users, to talk to the people that are actually going to use the program in their daily activities. So both pseudocode and flowcharts are very handy tools to start designing your first algorithms or start developing your first programs. Here you can see a sneak preview on object-oriented programming. I will quickly highlight a few concepts here. We will get into a lot more detail into each of these concepts into subsequent chapters. Here you can see an example of a Java object-oriented class definition. A class is a blueprint description for a series of objects. In other words, an object is an instance of a class, is a particular occurrence of a class. So here we have a class BMI calculator. BMI calculator is the name of the class. A class in object-oriented programming is characterized by variables or properties together with procedures or methods. Here we have two variables, or actually we have three variables. We have the weight, the height, and the BMI. A variable, you can think of a variable as a data element. Besides the three variables or properties, weight, height, and BMI, we also have a couple of procedures. The next procedure, or the first procedure we have, is BMI calculator. You may note that this procedure, BMI calculator, has the same name as the class. This is why we call this procedure or method a constructor. A constructor will allow us to construct objects from a class. This constructor takes two input parameters, weight and height, and will as such create a BMI calculator object. Besides the method or procedure BMI calculator, we also have two other methods or procedures. The next one is calculate. This procedure will calculate the actual BMI. And remember, the BMI here is calculated as the weight divided by the height times the height. So that's the only activity which this method or procedure will do. Finally, the class concludes with a third method, is overweight, to verify whether a person has overweight, yes or no. This simply will verify whether the BMI is bigger than 25 and so on. This is just the first example of an object-oriented program in Java. Don't worry if you don't understand the meaning of all the key terms that you see appearing here, like public, like double, like private, like this, like void, etc. We will extensively zoom into the meaning of each of those in subsequent chapters. Right now, it suffices to say that a class is a blueprint of a series of objects, and that a class is characterized by variables such as weight, height, and BMI in our case, and methods or procedures such as BMI calculator, calculate, and is overweight. Let's now zoom into programming errors. Unfortunately, as you will start developing your first programs, you will see that programming errors are likely to occur. A synonym for a programming error is a bug. So the procedure that is used to remove programming errors from your software programs is referred to as debugging, getting the bugs out. When you're doing debugging, there are various steps that you have to go through. A first important step is detect that there's an error. Although this may seem obvious, I can assure you that this is not always that straightforward to see that there's an error. We'll zoom into that in what follows. So first step is detect that there was an error. The next step is locate the error. Find the error in the software program. Finally, once we have located the error in the software program, we can try and solve it. These are the debugging steps that you have to go through as you start removing bugs or errors from your software programs. Note that it may well be that you have to do multiple cycles of this process. Various types of errors can occur. Syntax, compilation errors are one example, runtime errors, or logic/semantic errors. Let's zoom into each of these three types of bugs into more detail in what follows. Here you can see an example of a syntax or a compilation error. So we have a method, calculate. Remember, this was one of the methods of our BMI class. And the purpose of this method is to calculate the BMI. It is calculated as the weight divided by the height times the height. Now, one of the syntax rules in Java states that every statement should end with a semicolon. What we see here in this example is that it ends with a comma instead of a semicolon. So you can see that this statement basically is not obeying the syntactic rules put forward by the Java programming language. So as we will start translating this program or this class into machine language, our translator will actually throw a syntactic or compilation error. It will tell us that there's an error in the syntax. Obviously, these are errors which are very easy to locate and very easy to solve. We can just solve it by replacing the comma with a semicolon. A runtime error is an error which occurs during runtime. That means as you execute your program. Again, we have the example of the calculate method, which calculates the BMI as the weight divided by the height times the height. Imagine that during runtime, somebody enters a value 0 for height. Somebody enters a value 0 for height, and this is not appropriately checked by the program, then you will end up with a division by 0. As you will remember from your course in mathematics, we cannot divide by 0, so a runtime error will be generated. Again, a runtime error is an error which typically occurs during the execution, during the running of your program. Finally, we have a logic or semantic error. Again, we have the calculate method, but now the BMI is calculated as the weight times weight divided by the height. Obviously, the computer will not generate any errors here. It will just calculate an incorrect value for the BMI because the correct formula for the BMI is the weight divided by the height squared. Here it has been incorrectly programmed. So the logic or the semantics of our program is incorrect. It speaks for itself that these types of errors are very hard to detect because actually the program will give an output in this particular case, but the output will be incorrect. Given those three different types of errors that you may run into, it is very important that your program is appropriately tested. Basically, what you want to do during software testing is verify and validate your program. Verification refers to the fact that the program was correctly built. Validation refers to the activity that checks whether the correct program was built. So both are two different types of activities, and it speaks for itself that validation is a lot harder than verification, because in validation we are particularly interested in logic or semantic errors. We would just like to know whether the program gives us the correct output. So again, remember the distinction between verification and validation. Verification checks whether the program was built correctly. Validation checks whether the correct program was built. To decide upon the optimal amount of testing, it is important to be aware that the cost of testing will increase exponentially with the amount of testing. However, the cost of missed bugs will decrease exponentially also with the amount of testing. The optimal amount of testing can then be found at the intersection of both curves. It is important to make sure that you're not under-testing the program and also not over-testing the program. Various procedures can be used to facilitate software testing. First, we can desk check the program manually. We go through the program manually, inspect the various statements, and see whether they are correct, yes or no. Static testing refers to testing a program not by executing it, but by inspecting and reviewing the code. This typically entails detailed walkthroughs through the various code statements. This primarily aims at verification. Dynamic testing, on the other hand, will execute the program with selected test cases. When I say selected test cases, in our BMI example, you can think about specific combinations of height and weight. You can think of dynamic testing as being more related to validation. The test cases themselves can be selected according to a white box strategy or a black box strategy. A white box strategy means that we're going to get into the code in order to select the test cases. In white box testing, we can pay special attention to if-then-else selections in the code, to loops and so on, and carefully select our test cases so as to check any boundary conditions with respect to the if-then-else statements or loops. Test cases can also be selected according to a black box strategy. Black box means that we're not going to inspect the internal code, and we just select a bunch of test cases at random, not based upon any code inspection. One pretty exhaustive procedure would be to test all possible input combinations. Obviously, this is quite resource demanding. When testing, it is also very important to check what happens when impossible values are entered. Think about a negative value for weight, a negative value for height, etc. Software development is typically going to have two different phases of testing chronologically. Alpha testing is the type of testing which is done by the application developers or programmers themselves before the software is brought to the market. In beta testing, the software is given to a selected target audience of users, of end users, and errors can be reported back to the development teams. One of the final activities in software development is software maintenance. Maintenance refers to adjusting the program after it was taken into production. Maintenance typically consumes a large part of the overall software development. Some even claim that it can go up to 70% or more of the total software development time. Various types of maintenance can be distinguished. The first one is adaptive maintenance. In adaptive maintenance, you're going to modify the program to accommodate changes in the environment. When we say changes in the environment, we are primarily referring to the hardware and software environment in which the program runs. Think about a new Windows release. whereby some new features are added and some old features are removed. Hence, your program needs to be thoroughly aware of this, such that it can make use of some of the new features and such that some of the old features of which it made use can be removed. Perfective maintenance refers to the support of new or changed user requirements. Think about our BMI example, for example. There, the height was entered in meters and the weight in kilos. But imagine that you also want to run your BMI example or your BMI program in the UK, where height is typically expressed in feet and weight in pounds. So if you want to accommodate those new changed user requirements, you have to do some perfective maintenance on your software program. Corrective maintenance aims at fixing runtime errors during runtime. Let me do that again. Corrective maintenance refers to fixing runtime errors. And you can make a further distinction between emergency fixes, which should be fixed as quickly as possible, versus routine debugging, which is less critical. Finally, we have preventive maintenance. Preventive maintenance aims at increasing software maintainability in order to prevent future errors. Think about what happened with the Y2K or year 2000 problem, where companies massively anticipated date calculation errors in their software programs at the end of the previous century. Another example is a transition of many countries from their own independent currency towards the euro. Firms were also anticipating their software programs to both of these changes using the appropriate preventive maintenance operations. Among the 4 types of maintenance, perfective maintenance typically takes the main share of all maintenance efforts. Some say that it can even go up to 50% of all maintenance efforts. Finally, to conclude this chapter, let's highlight some of the key principles of structured programming. A first key principle is stepwise refinement. Programs or algorithms are typically designed using a top-down strategy. You will start from a high-level problem and then subdivide it into smaller, more manageable subproblems. Remember, both pseudocode and flowcharts can be very handy tools to do this. Documentation is also very important as you will start designing your first programs. When you do documentation, the aim is to clarify all kinds of programming statements that you are using. Good documentation will facilitate maintenance. And every programming language, also Java, has built-in facilities to do documentation. This is really very important. Finally, as we will start designing our classes or object-oriented classes, we will have to give names to the variables or properties and names to the procedures or methods. It is very important that you make those names as meaningful as possible. So try to avoid using names like I and J and K and L, but use names such as height, weight, BMI, calculate, ask for input, etc. Those are meaningful names that will facilitate the understanding of your programs also during maintenance. So remember, to conclude this chapter, we provided you with a step-by-step overview of the programming process. We also gave you a sneak preview on object-oriented programming, zoomed into programming errors, talked about the principles of software testing, software maintenance, and finished the chapter by reviewing the key principles of structured programming.